The meters in three-phase systems. First meter we're looking at is the wattmeter. When connecting a wattmeter, we have to remember that the wattmeter consists of two coils. The first coil is my current coil, which connects in series with the load, and it also has a voltage coil, LV. The current coil connects in series between the supply and the load. Let's say we've got a motor connected there, and we see that the voltage coil, which has a high impedance, will connect in parallel between the load or the motor. Current coil connects in series, has a very low impedance. It's important to connect it the right way around, otherwise we're going to burn out the current coil due to the high voltage that's being applied to it. Now, when connecting wattmeters into a three-phase system, we either use the 2 or the 3 meter method, whereby we've got our 3 supply voltages, one for each phase, which then connects to our 3 lines, and then this combination will be our wattmeter 1, and this one over here will be our wattmeter number 2. In order to calculate the total power in this circuit, we simply say P total is equal to P1 plus P2. The energy meter is also called the kilowatt hour meter, and that is what the supplier uses to determine our cost, or how much energy we've used over a long period of time. It does that by means of the same concept as the wattmeter, where it measures how much current flows, how much voltage flows, and it uses the generated magnetic fields to actually turn a gear, which in turn will cause a counter to measure how much current has been drawn over a period of time. The application or the connection of the energy meter is very similar to the wattmeter. Final meter is the power factor meter. The power factor meter, in the diagram we can see the basic construction, whereby it has voltage and current coils. The voltage coils are mounted 90 degrees out of phase with each other in a physical connection, and each one of those has a inductor or a resistor connected to it, which in turn will cause a lead or a lag in the current, and as a result the magnetic field that it generates, it then also uses that magnetic field generated to indicate what the phase shift is between the voltage and the current that is being supplied by the circuit. The wiring of those devices into a circuit is the same as for a wattmeter.